Good, you won't believe this. Good evening, everybody. My dog just demanded to go out. Bear with me 1 second. Dear, oh dear. There we go. Proof that these office hours are not pre-recorded. Good evening, everybody. Welcome to office hours. 30-second delay there for a damn dog, but he's actually got an injured back leg, so he's $2,000 in vet bills. But yes, he's being looked after with a very gentle touch at the moment. So yes, when he wants to go outside, he gets to go outside. Hopefully you can hear me and see me. That's all fine. The chat line should be open, so feel free to chat with each other, chat with me, etc. I'll try keep an eye on it as we go. Before we get started, I should say it. Yeah, bonus information. I killed off an old laptop the other day because it was getting long in the tooth, and I found this thing. Like, you can get the NVMe drive. Up there. You can get the. Is that going to focus on that? No. Smart camera knows what a human being is. There we go. So you can get like the NVMe drive out of an old laptop, and this little enclosure USB-C costs like $15. And now I've got like the world's fastest flash drive. Like no more of these old USB sticks. This thing is just absolutely fantastic. 256 gig. So yeah, before you throw out your old laptops, grab the M2 NVMe drives out of them and turn them into USB disks. Anyway, I digress. Let's share the slides and let's get on with things. As I always say, getting in touch is easy. All my social media things you can get on Linktree/Connor by scanning the QR code. My DMs on Twitter are always open. You can always message me on LinkedIn. My DMs on Blue Sky are always open. So however you'd like to get in touch, feel free. There's no drama at all. My job literally is to help customers succeed. So if you have any dramas, you don't have to always just go to Ask Tom or anywhere. We prefer that because the information we give then becomes public for everyone and everyone gets to prosper. But any way you choose to get in touch with me, we're always happy to help. If it's your first office hours with me, you'll see the content is somewhat often like a bit skewed either to the left or down to the bottom of the screen. That's so that when we turn this into a YouTube video, my ugly mug at the top right will not block any important content for you. As always, I like to start with some bits and pieces, mainly to promote the various user groups around the place and the conferences going around the place, because the more we can support them. I'm still a huge fan of, even though I'm doing this over Zoom, I'm a massive fan of in-person events. The concept of face-to-face, there's nothing that compares to it in terms of building a strong and rich Oracle community. As we speak, the Apex Connect conference is on. I think on the final day today, the third day. Fantastic event. I've spoken at it a number of times. Couldn't get there this year due to other commitments. But yeah, so Apex Connect, fantastic event. Also, as we speak, if you've never heard of this before, the Norway user group do their conference on a cruise liner. It sails from Norway down to Kiel, I think, through the fjords. Absolutely fantastic experience. As speakers, we love it because it's a captive audience. They really can't go anywhere because it's a very cold water to swim in. But yeah, if you ever get a chance to go as a speaker or an attendee, keep an eye on the Norway conference. It's around about this time each year. Absolutely fantastic and unique experience when it comes to doing a conference on the water. For me, next week, in 2 weeks' time, I'll be heading off to Florida for the Ascend conference. That's more of a sort of apps and finance and CRM style conference, but I'll be doing some talks there on some AI and actually a soft skills talk on how to present. Hopefully I don't do a bad job tonight and hopefully dissuade anyone. But yeah, so if you're in Florida, love you to come say hello. My first time in Florida. If you live or have been to Florida and you've got ideas of what I should do, please throw them in the chat line. All ideas taken with much appreciation. The week after that, I'll be at Kscope, probably one of the largest database developer events that goes around for Oracle. Heavy focus on Apex, obviously, and if you're into EPM, there's a sort of separate set of streams for that as well. I'll be very busy there at Kscope, but once again, if you're in town, that's in where is it? It's in Texas. So if you're anywhere in Texas, in the south of the US, please come along, say hello. Fantastic event. Literally dozens of streams, fantastic, a lot of content there. And yeah, I'd love to say hi. Next week, if you're in Europe and you've just been to the Apex Connect and you're somewhere in Europe, get on down to Italy. This one's in Milan, the Italian user group Tech Days. I've been there to the Milan a couple of times and the one they had in Rome. Once again, just going to Italy for the sake of going to Italy is fantastic for the food and the people and the culture and the history. But bonus Oracle content as well. How good would that be? For me, at the end of July, I'll be heading over to India for the annual Yatra tour. I think the agenda's out now. If not, the agenda or the list of speakers is. So we get a whole bunch of ACE directors. Some might even be on the call tonight. ACE directors coming along, plus some Oracle people coming along. It's an absolutely wonderful time. So if you're joining the call from India, make sure you come see us in one of those cities. And the couple of things on call for papers for those speakers on the call, or if you just want to do your first time, be a budding speaker, the EMEA tour, a whole stack of cities there. I was on this last year. It's going to be a struggle this year for me to get there due to timing commitments, but we'll do my best. But yeah, so if you want, you could do some, one, or all of those if you want to get involved with speaking at a conference. And also Cloud World, Oracle's main biggest event of the year. We're putting out our call for papers. I think it ends in about 2 or 3 weeks' time, so toward the end of May. But yeah, if you want to ever get to Cloud World and not have to pay the registration fee or not have your company have to pay the registration fee, throw in a call for papers, throw in a submission. I have to admit, it's tight to get one because there's a lot of people trying to get, accepted for a very small number of spots. But yeah, there's no harm in trying. You may as well throw your name in the hat, and who knows? If you've got an interesting topic, you might be there at Cloud World. Hopefully I'll be there as well. And finally, as part of the EMEA tour, probably the pinnacle or the largest part of the EMEA tour is the DOAG event, which is at the end of the year in November, but their call for papers is also ending soon. I've been fortunate enough to go to that event a number of times. It's in Nuremberg. It's a fantastic venue, almost custom built for tech conferences. Really enjoyable time there. And so yeah, if you want to go along, especially if you're a German speaker, fantastic event. As I always say, all of that is really just my simple way of saying support your local user groups. If you find your local user groups, whether they're just a meetup, whether they're an organized user group, even if you're just organizing lunchtime things in your own office, try get that concept of the more we can share information, the more we all grow as a group. Cannot stress it enough. The whole motivation for Office Hours, which was first launched by Stephen Feuerstein when he still worked for Oracle back in 2000 and when did we launch Office Hours? I think 2018 or somewhere around there. It's been going for 7 years. It's solely about trying to grow this idea of sharing information back and forth such that we can all prosper. A couple other bits and pieces. SQL Developer VS Code, a bug fix update went out just last week. So if to update this is really easy. You simply fire up VS Code, right click on the extension and say update, and it'll just do it automatically. But yeah, so if you haven't done that, get 25.1.1. That came out last week. A couple of key critical important fixes to 25.1. The other nice thing there is, if you've ever seen, we hosted an Office Hours a few months back on the SQL CL projects facility, the sort of source code control deployment mechanism with Liquibase and Apex all bundled up together. Really cool facility. One of the cool things is when we roll out new versions of SQL Developer for VS Code, it picks up the latest SQL CL. And when it picks up the latest SQL CL, it picks up the latest implementation of the project facility. So you get all these sort of bonus things just by updating your extensions in SQL Developer for VS Code. So make sure you do that. What are we going to talk about tonight? So this is the questions that have came in. One of them, I must admit, is not a question. I'll talk about that in a second. First question is the best way to add hash partitions to a hash partition table. A problem with query block names. The query block name hint you can use, and someone's saying they tend to disappear. An interesting exercise on Booleans. Now that we have Booleans in 23AI, the sort of subtle differences for the optimizer when it comes to Booleans versus expressions, and I'll explain that when we get to it. 8168, this is my personal thing. This is just something I was tinkering with today, so it wasn't really a question that came in, but I thought it was pretty cool. If you're on the chat line, if you're brave, 8168 is a number we often see when we're optimizing queries. If you know why, feel free to throw it in the chat line. And if you get it right, I'll give you a shout out. If you get it wrong, I won't give you a shout out. And then the other three questions that came in were parallel execution on the autonomous database. Some interesting observations there. How to do data pump when you've got mixed case object names. And before we even get to that, for the love of all that is holy, please don't have mixed object names, mixed case object names. And the last one, if we get to it, large strings in the sort of when you can have 32K as a varchar 2, someone's observed they were getting a much slower performance for some strange reason, and we'll look at that as well. Oh, first thing on the chat line. There we go. Judith said the default cardinality for a table function. And yes, Judith gets a shout out. Well done. It's one of those numbers that just pops up everywhere in your optimizer costings. Generally, you don't want it. And we'll talk about that tonight. So let us get straight into it. Okay, here's the first question that came in. It's about adding hash partitions. As always, as I said, feel free to throw things on the chat and I'll do my best to respond to them. I will note that a question came in literally on the official office hours page about 5 minutes before I'll start the webinar. So I won't cover that tonight. I'll put it on the list for next month, but I just didn't really have enough time to cover that off. Anyway, back to this. Adding hash partitions, here's the question that came in. We need more granularity with our hash partitioned table. Your video, thank you for watching my video, said it must be a power of 2. How do we add all the partitions we need at once? Because if you're going from, say, 4 to 8 or 8 to 16, how do we do it without having to do it one at a time? And my answer to that in sort of the too long didn't read is you don't. But let's explore why. Now, I want to give a bit of background rather than just assume that people are very familiar with hash partitioning. I'm not going to show you how to do a hash partition table, but we're going to talk about how the data is distributed when you hash partition a table. So here's a trivial piece of DDL. I've simply created a table. I'm saying, yes, my table is going to have 8 partitions. As data come in, the database will scatter the data through those 8 physical different partitions. Generally makes the table management easier because they're smaller segments and helps with things like concurrency and contention for hot blocks. Then I insert 100,000 rows. So, high school maths tells us that 8 into 100,000 should be about 12,500 rows in each partition. And that's exactly what happens. If I was to draw it as a little graph, as the data comes in, we scatter it through a hash function, and we end up with there or thereabouts about 12,500 rows per partition. If you don't believe my pretty graph, we can actually look at the data as well. And before I do that, let's do the same thing now with 5 partitions. If I do 5 partitions and scatter the data with 100,000 rows, let's once again use our high school mathematics. 100,000 rows divided by 5, that's going to give me 20,000 rows per partition, correct? That's not what happens. That's exactly not what happens. Let's have a look at what actually happens. If I have a 5 partitioned hash partition table, you typically see something like this. I'm not saying it's the 3 in the middle. I'm just saying that you'll see 3 partitions with 25,000 rows, getting us to 75,000, and 2 partitions with 12,500 rows, bringing us up to 100,000. And the question is why? You would imagine a hashing function by design is meant to evenly scatter the rows across all the partitions. And for the 8 partitions, that's exactly what we got. With the 5 partitions, this is what it looks like. Just to prove it's not a pretty graph, if I go count the rows, and I'm using DBMS row ID here, row ID object, to isolate each individual partition within my table, you can see I got 25,000 in 3 of the partitions and 12,500 in each. It seems like a bug in the hash partitioning system. We actually do this deliberately. We don't do this, just because it's a bug. It's actually deliberate. The reason we do it is, should you ever want to add more partitions? As this original question came in saying, I want to add more partitions. I want to get more granular for my partitions. If the rows were always evenly scattered, when you added a partition and you wanted to redistribute the rows, you would have to change all of the rows values and possibly move every single row. Because if I'm going from, say, 5 partitions to 6 partitions and all the rows are evenly scattered, there's a good chance that every single one of the existing 5 partitions will have some rows plucked out of it to actually put into the 6th one. The reason we have this sort of odd distribution here when we have 5 partitions is when I go to 6, I only have to do this. I only have to move 1/2 a partition worth of data, and I choose one of the partitions that has this doubled up value. If I go from 6 to 7, I'll grab another one of those 25,000 and split it in 2. And when I go from 7 to 8, I'll grab the final one, and then once I get back to a power of 2, I have an even distribution. If I go from 8 to 9, I only split one of the partitions and split that one out. That way, it's very efficient to increase the number of hash partitions. You only have to split one partition and move half the data. You don't have to redistribute all of the data. So we did this for a reason, and the equilibrium point is always on a power of 2. That's why, as the person said, my video said, always choose a power of 2 for that even distribution of values. Having said that, there is a way of doing it all at once. If I want to get from 8 to 16, I don't have to go from 8 to 9, 9 to 10, etc. I can actually just move the entire table and split them all out. The big question is that better? And so let's have a look, because the early days of splitting a partition, just one of the partitions, predates our beautiful now alter table move online facilities, which came in 12.2, the ability to change the partitioning system or partition an unpartitioned table all with a single alter table move command. So the big question is our old sort of technology of splitting one partition at a time worse, better, or the same as doing a nice simple alter table move? And I thought we'd explore that. Let's have a look. So what I'm going to do is I'm going to create two tables, and they're going to be identical. This first table is table called T. I'm just sticking it in a standalone table space. It's got 16 partitions, and it's 30 copies of DBA object. So what's that? About 30 times 80. It's going to be maybe about 2.5 million rows, somewhere around that. So large-ish, but not massive. I'll create another table that's exactly the same. It'll have one more row in it because it's obviously got the definition of T in it, but it's still just 30 copies of DBA objects. So two of these tables are, for all intents and purposes, identical. Now, I'm disconnecting from this session only so I can start a brand new session to reinitialize all my session statistics. So by disconnecting and reconnecting, I know that now my entire, all my stats in my session pretty much start at 0. With those stats starting at 0, I'm going to go ahead and do the old style mechanism, which is 16 times I'm going to go add a single partition. The database will grab one partition, split it in half, go from 16 to 17 partitions. Then it'll grab one partition, go from 17 to 18, all the way up to 32 partitions. So I actually ran this alter table command 16 times in a loop. Now, what it's telling me to then go to now is session number 2. So I can grab some statistics about what that first session just did. So all I'm doing now, because that first session before it did its work started afresh with fresh statistics, I'm simply taking a copy of all the session level statistics for this particular session, and which is effectively the sessions logged on as me and not the active one because it's this one. So it'll be the other session that's running, and it'll go pick up all the information from the previous command, which was just breaking those partitions into 2. So I'm going to disconnect again to get another fresh session now to pick up some new statistics, and I'm going to do the other way, which is with a single command now, I can simply say, take my table T1, which had 16 partitions, rebuild this table as a 32 partition table and do it online. So that's effectively the exact same thing, but rather than 16 individual commands, I've done one single command to go from 16 to 32 all at once. I can then go back over to session 2 and once again, grab a fresh set of stats for that new session. So this is all the session level stats for doing one partition at a time, and this is all the session level stats for doing all the partitions at once. And then I can run this query. I've got my two tables, stats1, which was session 1, stats2, which was session 2, and I can simply do a delta between all the various stats for all the critical things. How much redo did I burn? How many block changes did I do? How much physical work did I do? And I can do a comparison. So this is what we've got. So for example, just to pick some random data examples, for when I was doing one partition at a time, I read, 490 million IO requests. Was I got that right? Yeah. When I did all partitions at once with alter table modify, I did 578 million block requests, etc. So you can get an idea here of what the cost is. And the key thing really here is the delta line. Oops, let's do it with a Alt command. There we go. That's probably the key one. Wherever this delta is positive, it meant the all partition option was more expensive than the one partition at a time option. And so as we can see, with the exception of maybe this one, the amount of physical reads that were done in cache, and these numbers are tiny, everything else suggests that doing it one partition at a time is still the optimal way to do it. Yes, it's not just the lovely one-line command, but it is much more efficient. So there's a nice explanation for you. The best idea here is probably to do it effectively in the old style, one at a time. So as I said, one at a time is probably fine, even though we have this new modern operation. One thing I didn't check on here, which I probably should have, is whether you can do one at a time online. I assume you can. I should have added the online keyword here. I'll have to do some research there. But if that is a blocking operation, then maybe the extra cost is worth it to get that alter table move online. But once again, you've got some nice little examples here you could test yourself. But the key thing is, I think the old style is still the most efficient mechanism. Before you do any of that, of course, is ask yourself, are you solving the problem you're trying to achieve here? Because it's not common nowadays to need to split hash partitions very, very aggressively, unless you've got absolutely massive systems with a lot of concurrency. It's common to partition your indexes to avoid hot block concurrency, but since the advent of automatic segment space management, it's pretty rare to have hot blocks in a table. So just be aware of that. Just make sure you're trying to solve the right problem. Okay. Next question. Query block names. Here's the question that came in. We use query block names via the query QB block hint to help document our SQL and help troubleshoot execution plan problems. Excellent stuff. But sometimes the names simply disappear. What is going on? Excuse me. Oh, I should try to drink my water, not inhale it. I suppose the best way of describing this is the moment you give us an SQL statement to run, we, the Oracle database, we now own it. It's no longer yours, and we are free to do with it whatever we want in order to run it in the best way possible. To help explain what I mean by that cryptic description, let's do a demo. We're going to create a table called T1 and T2. They're very simple tables, and I'm going to do a series of queries here using our familiar QB name hint, which, don't get me wrong, I think is an excellent tool, not necessarily for digging into execution plans, but just for documenting your code. And let's see what happens when the optimizer gets a hold of those SQLs. So this is a very simple join. I've got QB name step 1. So this is step 1. I'm building up a query here. Step 1 is a simple join between these two tables with an outer join. And here's my plan. I'm just using select from DBMS display. And it says, yep, I did a hash join, but I don't care about that. What I'm looking for here is this part here. To get access to this, you use the plus alias in your format spec for your DBMSX plan. And as you can imagine, because there's a step 1 QB block hint in there, yep, here's step 1, step 1, step 1, step 1. It all makes sense. I can sort of tie that back to my original text. So far, so good. I can see that, yep, my query block name hint seems to work fine. That was step 1 of my query. I'm building a query up into a more complicated query to solve some sort of business problem. So step 1 is now this one. That's the existing query I just had. And now that I've done that, I'm going to do query block name step 2, which was querying from step 1 where C1 equals 0. So now I've got 2 query block names in there. So this is for that first inline query, and this is for my second one, once again to help me diagnose what's going on. Let's look at the execution plan, and we start to see some interesting things. Once again, the same hint report, the execution plan looks fine, but notice I've got step 1 and step 2 is gone. And interestingly, these ones, even though they're at step 1, are no longer step 1 out here. We've got this new SE $5E17, etc., some cryptic system-generated name. But the big question is, where's my step 2 gone? I just had that, right? And we'll do a few more examples before we reveal why. Let us charge on. Now I've got step 1 being this query, step 2 being the query we just saw, and that might be an input now into our third part of this query. So I've got a new query block name, which is step 3, which joins step 1 and step 2 on these queries. So this is a typical way we build up more complicated queries in a sort of bottom-up fashion. So now I've got step 1 as a query block, step 2 and step 3, and step 2's come back again. This is very strange. Step 1 is back, magically come back. Step 2 is actually there, and I've got a step 3 as well in there. So it almost seems like the more complicated I made it, it came back again. It seems very, very strange. Let me go back to this one, where now, rather than doing it just with a with statement, I'm going to have some database dictionary objects now. So rather than step 1 being a with clause, I'm actually have step 1 being a inline view, an actual database view. So there's my query block name in there. Do the same thing. I got step 2, once again querying now step 1, which is now a view. So I've got query block name step 2 in my query, and it's referencing step 1, the database view, which has its own query block name in there. And when I throw that in there, you know what I've got at the end of it? None of them. Step 1's gone, step two's gone. They're all gone, which is all a bit strange, isn't it? So let's dig into a little bit of reasons why and what's going on here. So let's focus on this last one first. Rather than just doing alias minus hint report, I'll do alias plus hint report, because even though QB name is not a performance-based hint, it's still a hint that the hint report can reveal to us. When I spit out that additional information for that query, it said, oh, I didn't end up using query step 1 because you've got the same QB name hints for 2 different query blocks. At which point you're going, well, hold on a second. I didn't see that. That doesn't seem to make a lot of sense because I simply had my database view and my query block name of step 2. How did I get 2 step 1s in there? Well, we have to go exploring. And one of the cool things you can do, this came in about 18C, I think, is if you have a query that is going to be transformed by the database before being run and optimized, you can do this, dbms utility expand SQL text. And what that will do is it'll say, here's the query that you're presenting. I'll show you what we're going to give to the optimizer, at which point, and then it'll be optimized in terms of, execution plans and stuff. So when I did this and I printed it out, it comes out looking a bit nasty like this, but I took the effort to actually format it. It ends up looking like this, which is similar to what your query was originally, but not exactly. What the database went, let me try again. What the database went and did was it grabbed the text of your view and brought it and inserted it into your query text. So because you had that referenced a couple of times, it said, you're doing my step 3 here from this one, which is the database view, and this one, which is the database view, and here's the query block name you actually put in your outer query. But you get an idea here of what's going on here. It's basically doing a lot of fiddling around here, manipulating your query in order to come up with a single query that it's going to optimize. And that's why we got the error, because step 1's referenced here, step 1's referenced there, and it says you've now got 2 query block names with the same name. So let's go back to the slides. So hopefully that helps explain. Even though we often write queries in sort of what I'll call a procedural fashion, we're trying to solve small parts of the overall requirement and we sort of use it as building blocks. We always need to come back to the fact that it's a relational database. It's all based in set theory, and so is the database execution engine itself. It generally is going to grab your query and reshuffle things around to come up with for what it thinks is the optimal single query to run. This element is called query transformation. There's a million different transformations that can occur. And if you ever do a 10053 trace, you can see some of these transformations as the parsing process goes on. Because of that, it's quite probable, I was going to say possible, but it's actually quite probable that your query block names may disappear or be thrown away or end up being duplicated. This is not me saying you should throw them away, but be aware of their general aim here. The aim is for you to effectively self-document your SQL queries for the next person that comes along to maintain them. So come up with some nice meaningful names inside your query blocks to help the next person in terms of data maintenance. Think of it as a guaranteed stored comment in the data dictionary itself. So that's the aim here, but be aware they are going to get reshuffled at execution time. Hope that makes sense. Booleans versus expressions. This one's interesting. Here's the question that came in. In 23AI, a predicate that we could historically call an expression could also now be considered a Boolean as well. If I had indexes on both, what is going to happen? And I thought this was a very cool question. This is someone sort of thinking outside the box. When I saw this email, I'd not even considered this as a potential possibility, but once it was thrown across my desk, I thought, that is a very interesting question. And I happily say I had no idea what was going to happen, so I thought let's write some little test cases and we'll go through them together and we'll see what the database does when it comes to handling Booleans that are really just expressions. So the demo will help explain what I mean by this. So we're going to start with some examples here. And even this first example sort of, makes you sort of double take when you start talking about Booleans. I'm going to create a table that's just a copy of DBA objects with 2 extra columns, which is mod row num2 equals 0. So this is an expression that obviously results in true or false, and so it becomes a Boolean column, a column called bool. And I've called it lots of true because mod row num2 simply toggles between 0 and 1. Out of my 80,000 DBA objects, literally half of them are going to be true, half of them are going to be false. And as we know, when you've got lots of values in there for the same value, indexes aren't that great. Whereas this one is different. This is only true when the row number is less than 10. So in this table here, I'm going to have 80,000 rows, 10 of which will be true in this column, and all the rest will be false. If I describe my table, it's just a copy of DBA objects, and you've got these two columns at the end. Boolean, which has lots and lots of truths in it, and a Boolean that has not many truths in it. And I'm going to put indexes on both those columns, because Booleans are just like any other column. You can index them, you can put constraints on all the normal stuff, and I'll gather some stats so the optimizer has all the good information. It knows that this thing, not a great index for true or false, because there's only two distinct values across the entire table, and there's 50,000 or 40,000 of each. Whereas this one, there's only a few trues and lots of falses. So an index query on true would be good, index query on false would be bad. So let's do some execution plans, see what happens. If I do select star from T where bool lots of true, it still messes with my head not doing some column equals something else, but because this is already true or false, we're bool lots of true. And the optimizer was spot on. It said, yep, I think I'm going to get half the rows are going to be true, so I'm going to do table access full. And then this, the obvious sort of counterpart or counterexample, where bool not many true, the database knew there was only 10 rows that had the value of true, and it said, yep, that's a great opportunity to use an index. So for a Boolean column, indexes work just like any other column. If the index seems an attractive option, the optimizer will choose it. If the index is not an attractive option, the optimizer will not choose it. So far, it's just like any other column. That's cool. Let's now create these tables, T1 with DBA objects, and I'm going to create an index now without the column. This is what we would do, prior to 23AI. If I wanted to have an index on an expression, I could do it as a function-based index. So I'm simply saying here, I'm going to create an index. It's a Boolean index because now this returns effectively a Boolean value. So I don't have the column anymore, but I have the function-based index on a Boolean expression. So if I do select count star where created greater than last DDL time, I've got an index on this expression. And so as we can see, there's only one row in there. So that's a great, that would be a great use of this index because there's only one value that's satisfied that's true here, just like our not many Booleans example we just had before. So I've got the index on created greater than last DDL time. I've done a query on created last than DDL time. Let's have a look what happens. Database doesn't use the index. It can't make that logical leap to go, oh, this is an expression. I have an index that's on that expression that results in a Boolean. The number of values for true is very, very low, and therefore I can use that index. The optimizer is not intelligent enough to make that leap. It still thinks this is a, do I have an index on created? Can I use it? Or do I have an index on last DDL time, etc.? It can't make that logical leap to this being a Boolean. It just can't. Even if I force the index, if I say, look, I know you've got an index on this expression. I want you to use that index. It will use the index, but not in the way we foresee, because you can see it's actually doing an index full scan, and it's only at this level, level 1, it's actually applying the actual result. So yes, it's using the index, but really it's using the index to scan every single row in the table. So we just made our query twice as slow. And then with each row, it's actually doing the check here for that filter. So it can't make that leap. What is interesting is if you actually add is true to the end of it, now it goes, oh, this is actually a Boolean, not an expression. Oh, do I have an index on a Boolean expression? Yes, I do. And it can now use the index and just get the one row. So it's that subtle thing there. This is that little gentle nudge to the optimizer saying, it's not really an expression. It's actually an expression that's a Boolean. So, it's these sort of interesting things. It would be nice if the optimizer could work out just that, but at the moment you have to do is true. Then I thought, well, maybe it's just the fact that, maybe indexes, if indexes don't know that every value is in the index, like if a column can be nullable, then sometimes an index doesn't reflect the entire state of the table. So I thought, well, maybe if I try just this and let the database know that, by the way, this expression is always going to return true or false. So it's always going to return not null, because if it doesn't, the database might not know that might be nullable, that might be nullable. So I'm going to let it know that is always not nullable. Will it use the index? Unfortunately not. What if I make those two columns? Same thing. Make them not null, make that not null, make all that not null. I could not coerce the optimizer to actually use that index unless I actually had the explicit is true. So interestingly enough, if I go add that column, it goes back to like the original example. So if I go back and recreate my table, actually add a virtual column, which is that exact same expression. Put an index on it, gather some stats. Guess what? Where bool, which we know is just that expression, literally that same expression, it can now use the index. If I do where bool is true, it can also use the index, as you'd expect, because obviously the previous one did as well. But if I go back to using this, and that is that expression, bool is created greater than last DDL time, the database still doesn't know. It goes, nope, that's not, I don't know what that is. Even though I've got a column called bool, which is exactly that, it can't make that leap. So it's just one of those things that, is currently, I'm not sure if we'll change it, but be aware of it, that just, you might actually need to add these virtual columns. Funnily enough, if I then say where this is true, it does know that, yes, this is actually a column called bool, and I can use the Boolean index. So there's this interesting thing. A few more examples for you. This is another one where I thought, well, what if we start doing, things like, rather than two different columns, an actual just a nice static value. So object ID less than 10, that's a Boolean index because the result of this is true or false. And I'll do a normal index on just the object ID. And you can sort of guess probably where I'm going here. I'm going to run a query which is that, and to see which index the optimizer takes. So I'm just going to do this now, where the T1, where object ID less than 10, which is both an index on that expression and an index on one of the elements in the expression. And as you might have been guessing from the previous examples, the database picks the normal index. It says, I'm going to use the object ID less than the value of 10. It can't make that intellectual leap to say that's a true or false expression. If I wrap it with is true, then thankfully it actually will use that Boolean index, but I still needed the is true here to coerce the optimizer into thinking that's a Boolean as opposed to a simple predicate. If I drop the index and then add a column, an actual explicit column, and create an index on it now, what do I get? If I do object less than 10, it still uses the normal index, even though it's got that virtual column. If I do where bool, it uses the Boolean index. Once again, good results, but not sort of the utopia we might have been after. And last one here, I think it's the last one here, I'll create a normal index on just object ID. If I do object ID less than 1 million, or 100,000, that's the entire table. So the database quite rightly says, I've got an index on object ID. This is a terrible index for this query because it is the entire table. I'm not going to use that index. Now, what I'm going to do is delete all the rows. Now, because I'm not changing the optimizer stats, the database still thinks that index is terrible for queries of object ID less than 1,000. The table is now empty. So you can see, even if I do this, less than 99,000, it still thinks, yep, that's a hideous index, right? Even though the table is now empty because I haven't updated the stats. But now I'm going to create an index on this value. Now, the cool thing is this index is being created after the table has been emptied. So if I go look at the table, the database thinks my normal index is 160 leaf blocks. And all those blocks have to be read because the database thinks, based on the old stats, that index is going to be terrible for a query that does this. But I've also told the database this index is incredibly fantastic. It's literally no leaf blocks. It's probably a single root block, right? It's literally the most efficient index you could possibly have on this expression. So I've done everything in my power now to say the Boolean index is an absolute banger. And when I try to do this query, which is the normal index is hideous for this query, the Boolean index is the perfect fit, it still won't use it. So it's just one of those unfortunate things. So that's just how we are at the moment. Whether that will change or not is up for debate. But as we currently stand, you need to sort of give the optimizer that little gentle nudge, that little helping hand to say, an expression is maybe not an expression. It's maybe a Boolean result of an expression. So hopefully that all makes sense. Okay, this one was not a question. This was just me being excited about something super cool coming in 23 AI. 8168, as Judith mentioned on the chat line, it's basically a sort of hard-coded magical number that you occasionally see in the optimizer, and it's generally when you see it, it's not a number you want to see. And let's explain why with a demo, and let's look at a cool thing in 23 AI that helps fix it. Let's see the examples where this number generally, let me start again. Let's see some examples of where the number 8168 appears, and generally, as Judith, as was suggested, oh God, I lost my train of thought. Let me go from the top. Whew, it's getting late. I'm getting old. The number 8168 is we see often when we're doing expressions on table functions in PL SQL. And it's Oracle's way of taking a best guess at the number of elements in a nested table or PL SQL array or something along those lines, pipeline functions, etc. To demonstrate that, let's have a look at a simple example. I've got a function here called returns some numbers. And as the name suggests, it returns some numbers. It returns this data type. Now, don't panic when you see this. This is me being lazy. This is just a pre-delivered by the database nested table of numbers. Sorry, it's a V array. It's a V array of numbers. So it's just a predefined data type. It saves me typing in create or replace type and having my own type. But it simply returns an array of 4 numbers. And I can actually select from that as a table function. If you've never seen nested tables, this is how they work. Anything that returns a V array or a nested table type, you can query it as if it was a relational table. And as we can see, returns some numbers, and we can see the source code above, simply takes that array and converts them to rows. Nice and simple, and as you can see, it's got 4 rows. I would hope that if the optimizer is working out the execution plan for this, it would know that there is 4 rows. Now, I can't gather table stats on this because it's not a physical object. So what does the optimizer do? Well, let's turn on trace only and see what happens. When you do this, select from table return some numbers. Here is our magic number, 8168. It literally went, oh, it's a nested table type. You've got 8,168 rows. It's literally that simple. It doesn't matter what you put in there. You could put in 4 rows as we got there. I could put in 4 million. Doesn't matter. The optimizer says you got 8168. And as we know, correct cardinality is everything when it comes to good execution plans. And so the most common time, often, the most common things I typically see in these kind of nested tables is people are storing elements in an in list. So it might be 10, 50, maybe 100 or so values. It's pretty rare to have 8,000 values or even more. So often this creates problems because the database now thinks it's carrying 8,168 rows into some next operation. And often, if this was, say, a list of employee numbers that you want to drive into the employee table, then hopefully you'd be wanting index access into the employee table. The database sees 8,000 employees and goes, yeah, let's do a full table scan, etc. So bad cardinality often leads to bad execution plans. So the other example where the database can get these cardinalities wrong, and this is not related specifically to 8168, is when you're using PL SQL functions of any type inside your queries. So I'm going to create an empty table T with a copy of DBA objects, and I'll put all the rows in there. I've done it as 2 steps such that there's no stats on this table. If I just did create table as select star and populated the table, the database kindly gives me all the stats I need just by creating it. Doing it in 2 steps here means I don't have statistics on this table. I've got an index on object ID, and I've got a function here now called return a value. And as your name might suggest, it simply takes a parameter and returns that value. It's a very simple function. So let's have a look at, once again now, a slightly different variant here, which is when I've got queries that are referencing PL SQL functions as predicates. And we often see this. So I'm doing select count star from T where object ID greater than return a value 100, which obviously returns the value of 100, or the object name equals Z. Now, the database says I did some dynamic sampling here. I don't have stats on the table. I'm going to do some dynamic sampling here and come up with an estimate, right? And that estimate is 7,336. Now, dynamic sampling suggests that it actually ran this query in some way, shape, or form to come up with some values to use as an estimate. So we often look at this and we take it on face value that it's done the right thing. Let's have a look at the actual result. When I run this query, there was actually 72,000 because almost all the object ID values are greater than 100 in this database, almost all of them, and that's almost false all the time. So it's really this one that's driving everything, and I literally got almost the entire table. My estimate was out by a factor of 10, which seems to run in the face of dynamic sampling. And the reason it does that is because dynamic sampling doesn't look at PL/SQL. So this gets eliminated from your dynamic sampling. It's simply looking at this kind of operation. We don't look at the PL/SQL functions when we're doing dynamic sampling. So let me flush the shared pool now and talk about how we've resolved this in 23AI. You can now toggle that facility. I can say, when I've got PL/SQL programs now in my queries, do I want dynamic statistics or dynamic sampling to actually access those functions as well? By default, it's not turned on, right? Or by default, it's set to choose. And choose means if you use the dynamic sampling hint, we might use it, but by default, it's not set to always on. So you can now set it at a global level, and I can query to see what the preferences are. I've now turned it on. Here is my return some numbers function again. As we know, it returns 4 numbers, and the optimizer thought it returned 8,168. Let's now redo that thing now that I've turned PL/SQL dynamic sampling on at this using my DBMS stats preference. And look at this. The estimate is now 4. The database saw this PL/SQL function. It saw that this table has no statistics on it because it's being synthesized out of thin air. So we do dynamic sampling, and the dynamic sampling now can go into and actually execute that PL/SQL function a number of times, and it says, oh, yep, you've got 4 rows. So immediately all those queries you used to have that had table functions and pipeline functions now have a much better chance of being optimized correctly, which is super cool. Let's now return to the second example, which is predicates that include calls to PL/SQL functions. Let's do execution plan on that. Remember I said the initial estimate was 7,000 rows. The actual was about 72,000 rows. Using some dynamic sampling, it now is much, much closer to the accurate result because it did include some references to this predicate because we've given it license to go run these PL/SQL functions to get some meaningful data out of it. So that's super cool. Now the question is, why not just have it on all the time then? Why wouldn't I just do this for everything? It seems like it's always going to make my stats better. Well, let's not forget that PL/SQL functions, not necessarily the fastest things in the world. What if my PL/SQL function, for example, is called return a slow value, which simply is going to return the same number again as pnum, but before it does that, it's going to burn a whole lot of CPU. What does dynamic sampling do? Dynamic sampling literally takes elements of rows of a table and puts the predicates through their paces to come up with some numbers, which means it might run this a lot of times based on dynamic sampling. So we can see here, I've said, I'm going to dynamic sample this particular query now, and all of a sudden, the cost of dynamic sampling might have even been far, slower than actually the cost of simply scanning this table. Because I ran this a whole stack of times, and each time I ran it, I did this expensive, calculation in here. That's why we don't necessarily ship it by turned on. You need to make some decisions here as to what you want to do. And of course, at this point, you're going, well, what if I've got some queries that use fast PL/SQL functions and some queries that use slow PL/SQL functions? I'm sort of stuck in a catch-22 here. Well, you'll be pleased to know that as well as setting it at the global level, you can actually set it at a object by object level. So I can say this null here is a package name. So if it's a package, I can do package name and function name. If it's just a standalone function like these ones, I simply null out the package. So I'm saying when I'm calling return a slow value, do not do dynamic sampling with that function. But when I'm using my return a value function, which was super snappy, then you're allowed to. And you have this really nice granular facility now to decide which functions you're going to include in dynamic sampling. And that's actually stored in your typical data dictionary. So in your users procedure table, we've got is dynamic sampling on, is dynamic sampling off, or is dynamic sampling set to choose, which as I said, comes into play if you've actually used the dynamic sampling hint. So that's A super cool thing that's going to resolve a whole lot of those costing issues for table functions in particular, but also PL SQL predicates in your SQL. So yeah, super cool, that one. Will we get 2 done? Well, we might get close. Okay. Parallel on autonomous. Here's the question that came in. We're trying to run some large queries in parallel on our autonomous database, but they do not seem to be running any faster than serial. How do we troubleshoot this issue? And I think the best way of describing this is lies, and the optimizer. And to explain what I mean by that, we have to jump onto an autonomous database. Let's do that. Now, this will be a little bit slow to click into gear here. I wanted an autonomous database with multiple CPUs. So this is the autonomous database I have in Phoenix, which actually has a lot of CPUs on it. So we can actually genuinely get parallel operations here, but we'll see shortly we didn't need it. But I just wanted to make sure we were doing it on a parallel system such that there was no oddities there. So I've got a table here, T. It's just a copy of the Scott.amp table. And before we talk about parallel, I want to talk about one of the really common lies we see from the optimizer, and then we'll see how it goes into the parallel discussion. Here's my table called T. It's a copy of Scott.amp. I've got an index on the employee number, and this is the common thing you've seen as an example of where the optimizer is differing between an execution plan versus explain plan. So I'm running explain plan here, select star from T where emp now equals B1, and it says, yep, that's going to use the index. And so into production my code goes, and it starts running really slowly. Why? Because the explain plan is not necessarily the same as the execution plan. And there's a whole lot of reasons why that might be the case, but this one here is one of the very original reasons that's always been the case from as far back as Oracle 7. If I actually run it and then look at the real plan, it was actually a table access full. Why? Well, I cheated a bit. The employee number in this table T was actually a string. I diddled it as I created the table. And so doing select star from employee where employee equals B1, that's a numeric bind variable, that's a string, and so the database put a 2 number around the employee number. Because there's a 2 number around it, I can't use the index, hence table access full. This is a time-honored example that's gone back all the way back to Oracle 7, showing the importance of getting your bind variable data types correct when they come to using columns. So this is that classic example of where explain plan suggests one thing, the execution plan proves that it was something else, and therefore you didn't get the results you expected. So hopefully you can see where this is going to lean into now parallel query not being used, but there's going to be a catch. So as I said, here's my employee table. I cheated. I put, it was actually a varchar 2, not a number. So let's now apply the same logic to a parallel query. One of the schemas that gets supplied when you create your autonomous database is the SSB schema, which has a number of large tables, one of them being customer. So I thought, let's do a parallel 6 query against ssb.customer. So I've literally put the hint in there saying parallel 6, show me the explain plan. And it says, when you run this, yep, we're going to use parallel query, all the PX normal stuff you see in your execution plan, and I'm going to do parallel query 6 because of the limit. I think, great. Now, there's a fundamental problem here. I'm connected to the low service on my autonomous database. You may remember we've got low, medium, high, TP, and TP urgent, and high and medium are the only ones where parallel is always on, and TP urgent, you can use it with a hint, but TP and low, you don't get parallel. So this is one of the examples. You think, this is explain plan, thinks I'm going to get parallel, but obviously at runtime, it's impossible because you don't get parallel in the low service. So let's now prove that. Rather than doing explain plan, we'll do like the previous thing. We'll actually run the query and then do dbms explain display cursor to see what really happened. And as we can see, there's obviously no parallel being going on. It says there was. Isn't that strange? It said that yes, at runtime, I did go ahead and do the parallel. Not an execution plan here. Okay, sorry, someone's a question that came in. Oh yeah, so Ronnie, this was just it was just an example of showing the difference between execution and explain plan. Obviously in a real world, I would simply I would correct my data type of either the column or the bind variable. I was just showing that the execution plan and explain plan are often different. Sorry, Ronnie, I should have explained. I sort of seen the chat. Where was I? Oh yes, so DBMS now I've lost, I know. Yeah, so I've run my query, and even DBMS explain display cursor, which shows the execution plan used at runtime, says, yep, that was parallel, and I used parallel 6. Now, is this a bug in autonomous? Because after all, when you connect to low, parallel is blocked. Yet here it says, if I throw in a parallel hint, the optimizer says, I did in fact use parallel query, even at execution time. So who's right? Well, let's go have a look at maybe it's a parameter. Maybe optimizer ignore hints was set and therefore it ignored that parameter, but that's false on autonomous. Used to be true back in the day, now on autonomous database, it's false. So your hint was not ignored. The execution plan says, I actually used it. It said, yep, I used 6 parallel servers. And the customer said, well, even though it says it's using parallel, it doesn't seem any faster than serial. Okay, so let me do a little tweak here. If you're not familiar with this, in SQL Plus in modern versions, you can also ask the database to give you the SQL ID of the query you just ran. So I'm going to rerun my parallel 6 query, and it said, yep, there's your SQL ID. Let's go have a look in $SQL and see what the runtime stats were for that SQL. So I can go query $, let's go back here. I can go query $SQL stats, which is more efficient than $SQL for my SQL ID. There's my SQL text. It has all the various bits and pieces here. The key thing to scroll back to is said, how many parallel servers were used to execute this query? And it said none. That's the key. Now, that lines up with the fact that I'm connected to the low service. But that does bring up a very important point with autonomous. We have explain plan, which says it's our first cut, our first guess at what we think the plan will going to be. Then we have the execution plan, what the optimizer believes it's going to go ahead and run with, right? It says, yep, I've done all my calculations. I know it's there. This is what I'm going to run. Let's now send it off to actually start running. And then there's another layer. Autonomous comes in and says, yep, I know you think you're about to run with parallel, but I'm not going to let you because you're connected to the low service where parallel is blocked. So be aware that the optimizer literally thought it ran that query in parallel, but it didn't. The only way you can really tell whether something was run in parallel or serial on autonomous, well, you can just believe in the services because they're obviously locked in, but you can go look at SQL and then look at PX servers execution. There's other things. You can look at the various VDOL views, PX sestat, PX session, etc. While the query is running, you can see how many parallel threads are actually going at the same time, and you'll generally see 0 if you're connected to one of the low services. But be aware that just look, that sort of common advice of, go look at the real plan using DBMS X-Plan display cursor. Even that is bamboozled by this. Autonomous can sneak in under the covers and go, nope, you don't get parallel because you're connected to the wrong service. So please be aware of that. And in particular, a worthy of note here. Well, let me best describe this. What that means is that you really want to avoid using a parallel hint. You're much better using parallel by connecting to those services that allow parallel query to run. Because the optimizer thinks you're going to get parallel, it's going to cost that query appropriately. It might have decided that an index costs this much, a full scan costs this much, but a full scan in parallel costs this much. That's better than the index. So you throwing a parallel hint in your query tells the optimizer, hey, guess what? You're going to get 32 parallel threads. It's going to be incredibly fast to scan that table. Forget the index. This is going to be awesome because we can get 32 full table scan threads going at once. And then when it actually gets to the actual engine, you got 1. So be aware that if you start throwing parallel hints in there and you're connected to a non-parallel service, the optimizer is blissfully unaware it's not going to get those options. Therefore, it might give you the wrong execution plan because it thinks full scans become incredibly faster or just parallel operations become incredibly faster when they're never going to happen. So be aware of that. It's important that you don't want to be using parallel hints unless you are explicitly in, say, the TP urgent service where they're allowed, or ideally just use the parallel native operations in the medium and high service. I hope that makes sense. Okay, unfortunately, that brings us to 10 o'clock. So let me jump to the end here. So as always, thank you very much for your time. As always, we didn't cover all the topics, but I'll cover them in the next office hours session. I've put up here on the slide, see you soonish. Why is that the case? Unfortunately, next month there won't be an office hours from me because I'll be in the USA for the Ascend and Kscope conferences. And there might not even be one in July because I'll be in Yatra. I'm not sure what date office hours is meant to be on. But unfortunately, yeah, so the next 2 months for me are very, very busy. So that saddens me tremendously. But as I said at the start of the call, I will always value face-to-face opportunities in front of Zoom opportunities, even though I really enjoy doing this. As always, thank you very much for giving up your time. I love doing this. The fact that you give up your precious work time or evening time to do this always touches me. And thank you as always. If you have any questions about this, you can always ping me on Twitter or Blue Sky afterwards. But until I see you next time in a future office hours, thank you again, and we'll see you all soon. Bye for now, everybody.